Hello everyone, thank you for taking time to join us in this webinar. I am Kevin Mungera from Winncom Technologies. I'm the RTM in, I'm one of the RTMs in MEA region, in charge of Africa region. Today we'll talk about Wi-Fi essentials and how to best select the right product for your Wi-Fi application. I do invite you to ask questions as we go on with the webinar. We shall discuss them more in the Q&A session. So sorry about that. We talked today about Winncom and our portfolio, our consulting and professional services. We look at the basics of Wi-Fi and Wi-Fi design. We look at IEEE 802.11 protocol, including Wi-Fi 6. And then we look at factors to look at when selecting your Wi-Fi device. Then we'll do a comparison between single and dual band routers, and then we sample some access points that you can use for your applications. So Winncom, we have our headquarters in Cleveland, Ohio. We have presence in North America, Latin America, Europe, Asia, and also in Africa. We have our sales and engineering teams located in all those particular areas. So our portfolio basically has technology solutions, which basically used to provide connectivity. And in technology solutions, we have LTE, we have point-to-point, we have point-to multi-points, we have Wi-Fi, we have distributed antenna systems, we have network and network management systems, and as well as network monitoring systems. Then in supporting solutions, we do have site solutions, accessories, power solutions, enclosures, and also IoT solutions and intelligent infrastructure. So our professional services basically aim to provide turnkey telecom solutions comprising of professional consulting services and professional engineering services. We have a global team of engineers who have specialized expertise in all these fields. In consulting services, we do complete solution proposition, we do custom accessories, we do project management, we do certified training, and we also have a training center. We do performance acceptance tests as well. In engineering services, we provide solutions both in wired and wireless networking services. We do design specifically for Wi-Fi. We do Wi-Fi planning. We have professional tools that we do use to model Wi-Fi propagation, be it for big venues, be it for hospitals, or any other kind of application. We do generate bill of materials for your project. We do extensive technical troubleshooting and support. We also provide in-house lab and testing of product and network monitoring. So we go to what's basically the basics of Wi-Fi. And basically Wi-Fi is an abbreviation for wireless fidelity. And this is based on the 802.11 family of standards. And it's primarily a local area networking technology designed to provide wireless broadband connectivity. And of late, this has become the de facto standard in the last mile connectivity. From your devices to access internet, most of them now come with the Wi-Fi capabilities. So a little look at the standards over the years. Basically, as I said before, Wi-Fi is based on the IEEE 802.11 standard, and the first standard of Wi-Fi came out in 1997, and that's the 802.11 legacy standard. And in that, the devices could only achieve a peak data rate of 2 megabits per second with a spectral efficiency of 0.1 bits per second per hertz, meaning that with 1 megahertz of frequency, you could only deliver 1 Mbps. And then we had the 802.11b in 1999, and the speeds improved in that particular standard to around 11 Mbps. And all the way now, the most common standard is the 802.11 AC and N. In N, we have it being ratified in 2009, and the operating band basically the 2.4 gig and the 5 gigahertz. And then the support was for 20 and 40 megahertz channel, and you could do up to 600 megabits per second, meaning that if you multiply the 15 by 40, you see that just your spectral efficiency is 15 bits per hertz, and 802.11n could support up to 600 megabits per megabits per second. And recently 802.11x, or as commonly known as Wi-Fi 6, was expected to be ratified last year, but I think the process is ongoing and it should be ratified maybe by the end of next month. In this standard, basically a client can get up to speeds of 10 gigabits per second with a spectral efficiency of 62.5 bps per hertz. And we have support for 20 megahertz, 40 megahertz, 80 megahertz, and up to 160 and 160 megahertz channel bandwidth. This means that you can achieve very high throughputs. And you have support for 2.4 and 5 gigahertz as well, meaning this one is backward compatible with the legacy standards. Key thing to note is that 802.11 A, B, G, and N the first four are legacy standards. The N is denoted as high throughput. The AC is denoted as very high throughput, and the AX, or normally known as Wi-Fi 6, is denoted as high efficiency. So basically, Wi-Fi 6 supports multi-user orthogonal frequency division multiple access. This basically subdivides the channel into frequency units called resource units that enable an access point to synchronize communication with many clients assigned to the resource units. So this facilitates provision of services to concurrent clients at the same time, rather than unlike the older legacy standard. And in this, we can achieve up to throughputs of 10 gigabits per second with highest modulation of up to 1024 quadrangle amplitude modulation. And the good thing about Wi-Fi 6 is that it supports both 2.4 and 5 gigahertz band and wireless devices. So the legacy standards devices can be able to run on a Wi-Fi 6 network. So for example, if you are in the medical field where you have equipment that were purchased back in 2008 or 2007 and they still connect to the Wi-Fi, you can be able to enjoy Wi-Fi 6 and still maintain your legacy medical devices. So the AC, this is just a summary of the Wi-Fi standards, and the AC supports up to 160 megahertz channel bandwidth, and basically AC works only on the 5 gigahertz band, and you can support up to 8 MIMO streams to support 4 users at a go. And some of the manufacturers have beamforming and band steering inbuilt to these access points on the 802.11 AC, so that you can be able to steer the band from one client to another depending on the client capability. And this also has downlink MIMO to support concurrent users on the same time slot rather than doing it sequentially. The other standard is the 802.11n. I'm just talking about the latest 3 standards that I use. This one has a peak data rate of 600 megabits per second. And it's backward compatible with older Wi-Fi standards as well. And it operates both on 2.4 and 5 gigahertz band like the Wi-Fi 6 standard. And it supports multi-user MIMO using a 2x2 antenna to send up to 4 spacious streams to increase the throughput. So which Wi-Fi device, based on the standards, based on the standards that you've just talked about, based on your requirement, which device do you select? So there are so many things to consider, but I just highlight the key things that you have to look at when deciding on the Wi-Fi device to purchase for your application. So the first thing is the number of clients and the density and the client density that you want to connect. So depending on the venue, if for example it's the stadium or it's a sports complex or it's a mall, there can be many clients. The client density can be variable, so you can choose the access point that you want to use for your Wi-Fi depending on the number of clients and the client density. If there's so many clients concentrated in a certain point, or you expect them to be concentrated in a certain point of your application, you can use sectorized access points. These have a narrow beamwidth that you can be able to focus and use many access points to serve many customers without generating self-interference. Then on the number of clients, different devices support different number of clients. You have some that support up to 64 clients, others 256, others 512, others 1,000 plus. So depending on the number of clients, then you can decide on which particular device to choose. Also, you need to consider the bandwidth requirements so that you provide the access point of the right standard to be able to sustain the requirement of the clients in terms of bandwidth. So the other thing is the location. And this you have to look at it in terms of whether it's outdoor or indoor, and the operating environment. It could be high humidity, there could be water, there could be oil. So you need to select the device with the right IP rating to be able to continue providing service in irrespective of the environmental conditions. Then the other thing is the number of service set identifiers, or commonly known as SSIDs. If you need, for example, to separate your accounting department from your engineering department to be able to run on separate Wi-Fi's or Wi-Fi SSIDs, then you need to select a device that has the number of, that supports the number of SSIDs that you require. If it's 5, it's 10, if it's 16, then you need to raise it as a consideration when you are looking for your Wi-Fi device. And then the size of the area to be covered is also an important consideration because each access point, Wi-Fi access point, comes with a different gain. And the higher the gain, the higher the coverage range. Although there are limits because of physics in terms of how far Wi-Fi can go, the size of the area to be covered needs to be considered so that you can be able to provide good coverage in all the areas that you want to provide. So using the area, maybe the plans of the floor plans, you can be able to, at Winncom, we can be able to design for you so that you know the number of access points you require, the placement that is optimal for the coverage to be the best. So in terms of the size of the area to be covered, as I've mentioned, so you look at the dimensions, the plans, the drawings, and using Using Wi-Fi design tools, one can create a coverage plan to provide an optimal signal. So as I mentioned previously, at Winncom, we have Wi-Fi design tools where you can upload your floor plans either in JPEG, PNG, or BMP, or if you don't have one, we can using a built-in drawing tool to create one from scratch. Then we scale your map and plan for the number and position of APs to achieve the desired coverage goal as per your needs. And then the other thing is the throughput requirement per user. Dependent on each user, you need to be able to know what is the throughput requirement per user so that you can get the right access point. And then you need to check the type of traffic to be sent over the wire. Is it data? Is it VoIP? Is it video? Is it combination of all those three? So that you can be able to prioritize. For example, if video in your business is a key element, then you need to select an access point that can be able to prioritize video traffic over data or VoIP. And then the other thing is that most of these access point comes with many features. So for example, if your application is just to provide Wi-Fi connectivity, you do not need to purchase a Wi-Fi device with so many other features that you do not need. Okay, so that's one of the thing that you also need to consider. So we look at the single band routers. As we mentioned, there are Wi-Fi standards that support single band, and there are Wi-Fi routers that support dual bands. So the single band routers basically operate on the 2.4 gigahertz band. These basically are the least expensive, and they are susceptible to interference from microwave ovens, Bluetooth devices, and cordless phones, as well as any other appliances operating in the 2.4 gigahertz band. And they are adequate for normal web surfing, email access, home automation, low data IoT, and light application of social media services. The other class of home routers or Wi-Fi access point is the dual band routers. And these are ideal for heavy usage. If you're streaming from services like Netflix, or you're doing conferencing on Zoom or Skype, and they do support the 2.4 as well as the 5 gigahertz band. And as we know, because the 5 gigahertz band supports larger channels, then most of the throughput you can get on a dual band access point rather than a single band access point. The channels in the 5 gigahertz are many and they are wider, while in the 2.4 band the channels are fewer and they are narrower. So an access point with the two bands can be able to provide you more throughput than a single band access point. And then the other important thing is that you can be able to share traffic between the two bands. You can categorize some devices to be accessing your connectivity through the 2.4 gig, and the other devices to be achieving connectivity from the 5 gigahertz band. You can do this in terms of the clients or in terms of applications. So the other important features to look at is if the devices have parental controls, or there is a possibility of timed access. This is important if you want to regulate or limit network access for some users or at a certain time. If, for example, it's in your office, you don't want people to access the network beyond working hours, you need to select a device that has that capability so that you're able to regulate or limit network access at certain times. And then the other thing, if you have priority for a certain service, if it's video, voice, or data, then you need to have an access point that has a quality of service capability so that you can be able to prioritize some services over the others. And if you have For example, guests, corporate users, various departments, you need to check that the device that you are looking for has the multi-SSID capability, that you're able to separate the guest and the corporate users or any other department that you wish to separate. Then the other issue is cloud management support. This is important nowadays, since you don't need to be at the venue where your devices are deployed to manage those particular devices. For example, if you are scheduling a deployment, you can be able to take the serial numbers of those devices, you do templates online, and then when devices are powered, they just download the settings from the cloud and you are good to go. You don't have to, if you have 1,000 devices, you do not need to configure one by one of those 1,000 devices. You only need to set a template and then push to all those particular devices, saving time and effort, and you're able to deploy your Wi-Fi without hassle. So we have many vendors in our portfolio that do provide Wi-Fi solutions, but I'll just mention a few. These are from Cambium Networks, the global manufacturer of broadband solutions. We have the enterprise family, both the indoor and outdoor. And these are basically 802.11 AC Wave 2. They also have a 802.11 AX or Wi-Fi 6 ready now. And this basically can serve various requirements, whether it's outdoor, whether it's indoor, whether it's a small number of users, if it's hospitality, if it's home. So depending on the requirement, you can be able to select your device as we have discussed previously. So if I look at one of the home devices, for example, this one comes with 4 LAN ports, 2 phone ports, and can support 64 wireless devices. So in the ports, for example, if you have a desktop, you have an internet TV, you have a printer, you have a network storage server, you have a fax and a phone, you can be able to use those ports in that device to connect to all your devices. And this is a summary just for the home devices and small office. You can see, as we talked before, there's support for dual band or single band, dual band being 5 gigahertz and 2.4 gigahertz. It's single band. You have the voice, it supports voice, which has PoE out to power the devices, for example, like cameras, and then fast Ethernet ports or gigabit Ethernet ports, and so on and so on. So depending on your application, you can be able to select the devices that fit your application, as we have discussed before. So thank you for taking time to attend this webinar. And if there are any questions, we can discuss them now. You can also send the questions to my email, which is down there, k.mongera@winncom.com, or you can also send a request to sales.email@winncom.com. Thank you so much for taking time to attend this webinar. Thank you and bye-bye.